this will be our final example of a rational equation that we need to solve. We need to find the LCD first. And to find that common denominator, we need to first make sure that all of our denominators are factored. The first denominator is just an x minus 2. We cannot factor that further. What about this denominator? We've got a nice trinomial, x squared minus x minus 2. We could factor that. We're looking for pair of numbers multiplied together as a negative 2, but added together as that negative 1. So I like positive 1 and negative 2. Our last denominator, the one on the right side, we could not factor that, so it's x plus 1. So thinking about the LCD, the common denominator, we need to use all those different factors that we see, but don't think about we need to use the total number that we see. It's just about how many do we see per denominator. Let's talk about the x minus 2. I see it once in this denominator, and I see it once in this denominator. The most I ever see it in a spot is just once, so once is enough, x minus 2. Same idea for x plus 1. Here it's once, here it's once, so once is enough, x plus 1. Now I'm going to rewrite the problem and leave some space to multiply in the LCD. Let's go for that. X over x minus 2 minus 3x over, I'll write these denominators in factored form, x plus 1, x minus 2, and on the right side equals 1 over x plus 1. And now I'll write in multiplied by x minus 2, x plus 1 over 1 to the first term, and to the second term, x minus 2 times x plus 1 over 1, and also to the third term, the right side of this equation, x minus 2 times x plus 1 over 1. Okay, what do we like to do at this point? It's one of my most favorite things to do. It is get to cancel. X minus 2 with x minus 2, smash. How about from our middle fraction here, we've got lots of canceling. X plus 1 with x plus 1, and x minus 2 with x minus 2. Cancel, cancel. And on the right side, x plus 1 with x plus 1. Now I need to be cautious with bringing down what is left over. From the first fraction, I see that I have left over an x and this x plus 1 in parentheses. I'll bring those down. X times x plus 1. From the middle, it's a minus 3x with nothing left. Everything else was canceled. Minus 3x. And on the right side, we have a 1 times x minus 2. If you said, well, that's just going to be an x minus 2, absolutely, I agree with you. I just wrote it in there. I go slow through these problems, and that's something that I choose to do when I get to problems that I know are lengthy and that have lots of opportunities to go off path. I slow down. At this point, I do everything slowly, but when I get to problems in particular that I know I mess up a little bit more often than other ones, I just go slow. I say to myself, it's okay to write extra steps in this problem because it keeps me on track. That makes it worth it. Next is do our multiplies. We have a cleaned up equation to try to solve. We've got a distribute here we need to do, and may or may not need to do a distribute there depending on how comfortable you are with saying, well, 1 times anything is just that anything. Let's go through. So x times x is x squared. X times 1 is going to be our 1x. We have a minus 3x to bring down. And on the right side, x, 1x minus 2. Now this one for certain is it's going to be a quadratic. I see that I have an x squared there, and I don't have any other x squared that maybe is going to cancel that one out, like how we saw the previous example work out. So as soon as I see an x squared, I say my moves are going to be bring all of my terms over to the left side and have it equal to 0 on the right side. So let's start to do that. I do see some like terms there. We could combine a positive 1x with a negative 3x. That's a negative 2x. Bring down that x squared. X squared minus 2x equals x minus 2. And now I'll start to cancel these terms off of the right side. Take away x from both sides. Cancel there. X squared minus 3x equals negative 2. And let's cancel this negative 2 with a positive 2. And watch what I'm going to do with this plus 2. I know that this positive 2, the constant, is not going to combine with an x squared or a negative 3x. And I don't want to go off path there by trying to add a 2 into one of these terms. So I have it off to the side here where it's basically going to end up on the left side, x squared minus 3x. There's the plus 2, and it equals 0. Now these moves are the moves that we do to solve a quadratic equation. This is called putting this quadratic equation into standard form. All of the terms on one side equal to 0. And we have some options about how to solve it. My first choice is if we can factor it. That's usually the quickest way to solve a quadratic. I have all my terms on the left side equal to 0. So I'm thinking, how can I factor this trinomial on the left side? Pair of numbers. Multiplied, they'll equal a positive 2, but added together equals a negative 3. These have got to be both negative. Negative 2 and negative 1. Once we have it factored, we can split those factors up and look at x minus 2 equals 0 and x minus 1 equals 0. The quadratic equations are often giving us two answers, and here's one way that we can see how that happens. Once it's factored, we say maybe the x minus 2 equals 0, or maybe it's the x minus 1 that equals 0. So let's solve these two small linear equations. Add 2 to both sides, cancel, so we're looking at x equals 2. And this equation, x plus 1 equals 0. Let's add 1 to both sides. Cancel. We have x equals 1. So we have two solutions. We have x equals 2, and we have x equals 1. But with these problems, it's not safe to just end it. We need to take a quick look back up to see, well, what are some solutions that would be no good? What would be those extraneous solutions? Let's consult the denominators. X minus 2. We do not want x minus 2 to equal 0. We do not want that denominator. Don't want it equal to 0. And if I solve this one, I'm seeing we don't want x equal a positive 2. Positive 2 is a bad answer. That was one of our answers. All that work for nothing. We come down here and say, sorry, it really was not a valid solution. Didn't check. You could say it doesn't check. You could say it's an extraneous solution. It's an invalid solution. You could say it makes a denominator equal to 0. Some way we want to convey that even though we did all sorts of excellent work here to arrive at these two answers, just because of the type of problem that it was when it began, 2 would not be an acceptable solution, so we have to throw it out. Gone. There are a couple other denominators to check. So once it's factored, that's a way we can see some values that would make our denominator equal to 0. If we factor it, then we have to be concerned with both of these. Now that x minus 2 is matching up with that x minus 2. We've already established that we don't want to have a positive 2 for an answer. But we need to think about x plus 1. We don't want x plus 1 to equal 0 either. X plus 1 should not equal 0. And if we solve that, we end up with x should not equal negative 1. And notice we'll get the same result from this denominator, another x plus 1. That's going to give us the same bad answer, x should not equal negative 1. Oh, this was good though. We ended up with a positive 1. That makes it okay. It's not a negative 1. If we had a negative 1, we'd toss that out also and say there's no solution to this problem. But since we had a positive 1, that works, And it turns out that that is going to be our one and only answer for this problem, x equals 1.